I'm Ed Tanous. I work for Nvidia today. I'm an OpenBMC maintainer. I maintain a lot of the subsystems that OpenBMC uses, and I was one of the original authors on a lot of the things that people now contribute to. These days, I do a lot of LLM systems, inference, that kind of thing. But I still maintain OpenBMC large components. Like Patrick, I looked it up after he said, I spent $94.53 last month on LLMs. And while sitting in that seat, I fixed one of the OpenBMC upstream build issues this morning. So yeah, if it builds today, be happy it does. You're welcome. So Nvidia uses the hell out of OpenBMC. Most people in this room are probably consuming at least one instance of OpenBMC from us. The rack that's there, which one did I pick? Oh, yeah. So that's a GB200 rack. In that rack, there are somewhere in the range of about 60 different OpenBMC implementations running in various capacities. Some of them are based on DCSCM. We maintain two different platforms in upstream. We maintain this one that's here as a reference, and we maintain a NVLink 32 slash CX8 as a switch reference in upstream. We use those primarily for contributing upstream so that we can go test our changes against real upstream platforms, run QEMU, run it on a real platform, etc. We also open source NVBMC, which is our fork, much like the rest of you, of OpenBMC. It's supported across about 20 different systems, depending on how you count. There's rack managers, a bunch of various different system implementations. In this rack that you see here, there's about 3 or 4 different OpenBMC machines that we publish. We also publish reference for some of the Bluefield stuff, so the NICs BMCs that run. And we've made huge and extensive changes to OpenBMC to support our products. We've upstreamed some of those. We've kept some of those downstream just for time to market. But by and large, all of our patches are available for you to pull. Pretty much every subsystem that we've modified or created, we publish to GitHub. These days, I think we publish it every half hour, so it syncs to our internal. And you get the source truth of what we're working on. The only thing we don't publish are unreleased system and just the meta layers to hopefully protect the innocent. In our fork, we've got about 100 plus new entity manager components, so different components of these various racks and systems that are now supported. Like I said earlier, we open source everything we can without legal issues. There are some cases where we have licensed code or we have licensed IP from others, and they bar us from releasing it. But our goal, by and large, is to make everything we do open source and available. And in fact, we're working on open sourcing more components of the stack, namely the HMC, in the next couple months. How much of that makes it into upstream? We'll see how much the community wants and how much we want to pull over. But the point is it's available. We also publish a reference MCU design that handles MCTP and other things, very similar to some of the other ones that exist in open source already. So For a minute here, I want to talk about what system racks look like today. This is intentionally simplified, intentionally kind of abstract, squint your eyes, not really reality. But in one of a reference rack, right, you will see several instances of OpenBMC. You will see several instances of OpenSMA, which is our microcontroller, and you'll see that repeated across the system. That's for various reasons, and there's various interconnects between these that aren't really important to this slide. And every single layer of the stack publishes a different API with some different constraints. Some of them are similar, some of them are not. Going forward in the next few years, system topologies are getting more dense. This design will not survive for more than a generation or two. And what we're seeing is because everything's now water cooled, things can be made significantly denser and you can get more compute into the same square footage, which also is reducing component count and a bunch of other things. What that means for manageability and OpenBMC as a whole is it means that some of those system components are going away. If you look at these, you can kind of see them as ascending orders of generation and size. The middle is kind of where we're at now. And you'll see things are getting significantly denser. On the far right, each one of those compute blades is roughly the equivalent of 2 or 3 of those silver ones on the far left. So we are physically running out of space to put manageability components, BMCs, HMCs. Where that starts to matter is when we need to start looking at how do we do these interconnects without having whatever it is, 18 HMCs, 18 BMCs, a rack manager, etc. Right? And if you look at where the green line is drawn, that's the farthest distance you have to reach for your manageability structure. It's not really correct. Technically, you have to go corner to corner in the rack, but right, that's how far you realistically have to reach. Today, we use a ton of I2C. We run it at various speeds. A lot of them are 400 kilobit. Where servers are moving to is they're moving toward USB. At least in a lot of our designs, where you have BMC direct into your manageability components, largely because it can span that whole green gap. It can get you from corner to corner on the rack in basically a single run without signal integrity issues. Can't really do that on multi-drop I2C or SM bus. The other thing that's driving it is it's commodity hardware. USB is everywhere and ubiquitous. You have a million vendors you can pick from for USB. So what that looks like in the rack going forward is it kind of simplifies this down. And again, I think I said this is 84% accurate now. We're dropping our accuracy as we go, right? A bunch of those intermediate components start going away because we physically can't fit them. And what that means is each of these green blocks, you now have to have one BMC or one OpenBMC connected to all of them and managing all of them. This is, again, intentionally simplified. In reality, there's 36 of those green blocks, right? Like this looks very much like a Yosemite meta platform or something, right? But when you multiply it by 36, you get into kind of weird territories where OpenBMC needs to evolve a little bit. The other big thing this gets you is now this middle BMC module can be multi-vendor pretty trivially, right? Almost every vendor has USB. I'm going to say every BMC provider has a USB. So for the same hardware, you can now swap these things out. There are racks entering OCP and other things now where the management module is actually physically separate and swappable in an L12 or L11 without having to manage anything or without having to open the rack. So there are system designs where it is intentionally swappable between vendors over life cycles, et cetera. And again, this is now 46% accurate. What does this have to do with OpenBMC? This is a significantly more complex software architecture for OpenBMC, even though we're simplifying hardware. We need to be able to manage 36 systems in a rack. There's no system in the tree today that does that. There's no system in anyone's fork that I'm aware of that does that. When you look at kind of the back of the napkin telemetry numbers that you guys were just talking about, right? To get every piece of telemetry off 36 blades once a second through a single processor, you're starting to look at numbers that you need to actually start optimizing your code. Very few people have accused OpenBMC's implementation of being optimal. So these are things we need to start looking at and caring about, whereas previously we didn't, right? And there's a lot of avenues you can go. There's a lot of ways we could go build these in open source. Ideally, in open source ahead of these systems that need them. And at least at Nvidia, we have a very large team of people looking at this and trying to give open source solutions, contribute things back, et cetera. What else did I have on my slide? So the USB link in the previous one is being standardized as part of OCP. It is called OBMF. They are probably going to have a standard. Actually, I don't want to give a date because I don't know the date. But those standards are coming. And one thing we need to start doing in upstream is preparing for these standards that are going to start running 48 megabit line rate worth of telemetry through them and get them to the greater network. And like, there's ways we could do it on dbus. There's ways we could do it without dbus. Some of the most prominent OpenBMC forks forked because of IPC as their primary reason. In upstream, I think this is a problem we can solve. A lot of smart people in this room, a lot of smart people working in upstream. I feel like this is a problem everyone has in common that we can go figure out. The other big thing this changes is we need to start getting things that are common. A lot of these new LLM systems are coming online very, very quickly. And data centers are wanting to swap out one or two components and then build the whole thing, deploy it at scale, and do that in an order of weeks or months. The software architecture needs to handle that without needing to rebuild the whole stack for an entire platform all at once. And I don't mean rebuild. I mean like re-engineer the entire stack for your new platform. Entity manager configs come into this a little bit because they are the first step to try to kind of make those things portable and separable by component. We need to go a lot further than entity manager goes today. This is one platform in the tree. I will not say which platform it is to protect the innocent. But it required 222 text files to do a platform port for one platform. And what's that? 12,000 lines of code or config. As these systems are rolling out, we cannot be writing 12,000 lines of human written code per system if like OpenBMC upstream is to survive and prosper, right? I'm sure every line of this code was reviewed very, very well, very deeply, and tested perfectly. So one thing that people tend to bring up in this is, where do standards fall into this? Standards are great at coming up with a standard that meets, has the possibility of meeting all use cases. Redfish at this point, I looked it up, is 10 years old. So it is a decade old, deployed across God only knows how many systems. Dbus is 20 years old. HTTP that Redfish is based on, 29 years old. In embedded, none of these standards are terribly easy to develop for, right? I'm sure most of this room has at some point debugged some Redfish API that didn't work. Where I think we can do, and to extend Patrick's analogy from earlier, is we can have the OpenBMC ranch where we can wrangle the llamas and turn them into cattle, right? We can take this wide array of standards that we can go implement and go standardize it to a level of, here's the defaults you get when you are managing a system, and here's the default tests you need to go pass. That's where I think OpenBMC adds value, is trying to constrain things to implementations that people can actually use. So to do that, upstream really needs your help. Ways you can help. So these days, LLMs have really changed how we code, right? I can write an OpenBMC module in an hour that would previously have taken weeks, and it'll be mostly correct. That doesn't mean it's common. That doesn't mean it's tested. That doesn't mean that other people can benefit from it. So sending code isn't always the answer. One thing that we're really hitting is reviewing code, reviewing changes, reviewing designs. There's a huge bottleneck today, where there are experts in the field and there are patches being submitted for things that they are experts in, and they almost get no feedback. And I'm guilty of this too. I mean, I review as much as I can, as much as my job allows, but the more the community actually reviews and tests and builds, right, the more we can actually build some of these kind of really neat racks and go build stuff that actually fulfills a real need. One thing I'll leave with is code itself is not a gift. It's actually, code on its own is a burden. And I say that as somebody who maintains a lot of code he didn't write. A lot of code I don't even understand. Where OpenBMC, I think, needs help is we need to build common solutions. We need to get them reviewed. We need to get them through security scanners. We need to get them past where an LLM can go find a security bug in your prettily written LLM code. And we need to make all those implementations available for everybody.